Heinrich Schmidt Partners are widely recognized in the construction industry as the best in formwork technology, with innovative designs and techniques that are unique and often imitated by their competitors. Since 1964, the team at Heinrich Schmidt Partners has been designing and constructing throughout the Australian and international industries. That team, which combines experience in all facets of formwork, from design to off-site engineering, transportation and on-site construction, gives Heinrich Schmidt Partners its well-deserved reputation for excellence throughout the industry. A perfect example of this excellence is the design of the A-frame that allows one pickup point on a large table form. Normally, one pickup point in the center of any flat surface means very little control over the way it swings and sways as it is moved. The normal procedure has been to use 4 pickup points, one on each corner. With the Heinrich Schmidt system, the A-frame is landed over a central hole which contains a lifting eye bolt below plywood level and enables a person to engage or disengage the chain hook from above or below. As the crane then takes the load of the table, a unique lever system operates which reverses the forces. This means that the harder the crane lifts, the harder the A-frame will clamp onto the table form. And because the pickup point is high, the unit becomes a stable inverted T-section that makes lifting and movement both efficient and safe. This system reduces the time from when the A-frame is first landed on the form to disconnection after moving to less than 5 minutes. Another unique feature which works in association with the A-frame is the transporter. The transporter is a carrier of table forms. It features a mast with a head frame, the machine itself, and a tripod foot. The mast and head frame can be raised to any height up to 6 meters and rotated any direction 360 degrees. The machine itself will move forwards and backwards and steer normally. The tripod foot can be lowered to the ground. The machine can then raise itself on that foot with load and rotate to any position required. This means the transporter has ultimate maneuverability. The transporter is used to strip table forms from underneath and either transport them to the edge of the building, to a loading platform, or a new location on the same level. The head of the transporter incorporates a sliding section and counterweight. It means it is possible to slide a table form forward on the head, sufficient to take the center eye bolt in the form beyond the edge of a building, which means it can then be picked up by the A-frame. The transporter can therefore move to any point on a building and provide access for the crane with or without the necessity of a loading platform. The transporter is most efficient when using the loading platform during non-peak hours to remove and stack table forms. Once the support system is placed on the new floor, then the forms can be brought from the stack and quickly and easily placed with the A-frame and crane. An alternate device for the same operation is another invention by the Heinrich Schmidt team. Lift with a specially adapted rotating head bolted to the top. It also has a side shift mechanism which enables accurate alignment of the forms. With the company emphasis on safety, flexibility and efficiency, all these machinery have approval of the Department of Labour and the various unions. Forklifts are also used to transport the scaffold towers complete. This means that on a shopping centre site, it is not necessary to dismantle the towers and reassemble them in a new location. The towers are carried with special slippers on the end of the normal tines. These slippers also have a fastening device which prevents the tower slipping off while being carried. Quite apart from the transportation systems, there are also the forms themselves, which, because of their design, make for efficient formwork construction. The table forms are designed specifically with a timber surround so that they can be added to from any side. The principle being that as far as possible, table forms be made to standard sizes which may be used across any construction job. Essentially, there are beam forms and slab forms, with the beam forms being placed between the columns and the slab forms being placed between but partially supported by the beam forms. The idea is that they be placed 400 millimeters apart so that standard plywood infills of 400 millimeters can be used up to the perimeter gap, which may be non-standard and require specially constructed perimeter table forms or plywood infills. The scaffold support system for these forms is designed to carry the maximum likely weight, and depending on the application, can be placed closer together for heavier loads or further apart for lighter loads. On the morning after pouring a slab, columns are set out and concurrently lines are snapped so that support towers and hence tables can be correctly placed. The scaffold support system is essentially very simple, with different size H-frames for differing height requirements and braces for support. These frames in turn have varying attachments such as screw jacks, flat jacks and tube extensions with U-heads, which can be placed in the top or the bottom of the H-frames and can provide support to any height configuration. They are easily transported either complete or broken down into component parts. A unique support designed and developed by the Heinrich Schmidt team is the external beam facade system. This system provides a safe working area for the placement and removal of external forms, steel fixing, the attachment of uni-struts and external items to the beam forms. It saves the problem of external scaffold placement for the setting of the perimeter beam construction. There are also various types of column forms. These vary considerably in shape, size and configuration, but the essential similarity is that they are all forms that can be reused and can be easily broken down and reset as required. The method of sealing and setting the forms varies from hinged on one side and bolted on the other to separate halves bolted both sides, or a new innovation, columns with their own stabilizing frame on the back, which gets bolted back to the previously poured column. This means the forms can be parked without dismantling and without the necessity of storage space. Then there are the wall form systems, which employ innovative use of captive wing nuts attached to the steel wailers. This means the form wall can be fixed from the inside, again without the complication of external scaffolding. There are also stiffening beams at the top of these forms to ensure straightness. Supports for the wall forms are via the adjustable push-pull props fixed to the floor. The most mechanized of all the Heinrich Schmidt Partners systems is the Lubeca hydraulic jump form. This incorporates many of the innovative features of the Formwork systems specifically adapted to center core construction and provides the most efficient, fast, accurate and safe jump form system available. A further system which has evolved from the ongoing company research and development program is the Heinrich Schmidt High Riser, a complete self-elevating construction system. The High Riser will allow construction of vertical concrete elements ahead of the main slab construction and enable other trades to work externally off suspended, fully enclosed work platforms and/or monorailed swing stage scaffolding. This means special finishes can be applied, beams stressed, precast placed and windows and curtain walls installed. Not only will this be a world first, but with patent registration numbers obtained, will soon revolutionize the process of building construction. Yet it will still be compatible with all existing Heinrich Schmidt Partners systems and give total construction flexibility. The basic principle upon which the company operates is that for a business to be successful, it must be the best across the board. With the High Riser, Lubeca and the general Formwork systems, Heinrich Schmidt Partners maintains quality control across all processes by designing, manufacturing, organizing and transporting all materials required. everything is considered to provide the best quality for the client via the most efficient, highest quality product that Heinrich Schmidt Partners can provide. Heinrich Schmidt Partners, world is in Formwork technology. Lubeca is a name synonymous with state-of-the-art in jump form technology. It is the most cost-efficient, safe and accurate jump form system available. A world leader in high-rise core construction. The Lubeca Mark II is a new, improved jump form system designed for the rapid and economic construction of tall centre cores in buildings, civil structures, silos, or any other tall structure with predominantly vertical concrete elements. Like all good inventions, the concept is simple. This caterpillar is exhibiting the simple principle upon which the new Lubeca system is based. Lubeca uses hydraulic rams to jump the system upwards. By means of pre-moulded pockets strategically placed in the wall at each level, the jacking beam is provided with a base from which to raise the whole superstructure. And once raised, the upper pockets provide the shear key beam with a position from which to raise the jacking beam, all from underneath the superstructure. Thus, with Lubeca Mark II, we have a completely self-contained jump form system that builds a section of tower, on which it then climbs, to build the next section of tower, on which it then climbs, and so on. Heinrich Schmidt, the inventor of the system.
Between 1972, when I invented the first Lubeca system, and 1987, the conditions and requirements of various authorities have changed considerably. Unions, developers, architects, engineers, lift installers and builders have steadily become more demanding. So much so that in 1985 I decided to design and develop a second jump form system, capable of satisfying even the most stringent requirements. Safety, simplicity, flexibility and economy were at the top of my list of priorities. The new Lubeca Mark II was introduced to the industry during May 1987 on a project for Civil and Civic in Victoria, Australia. Since then, I'm proud to say, in just over 12 months, we have already successfully completed several projects. 9 current projects are under construction, and we are manufacturing equipment for a further 3 projects. In other words, in that short time, the Australian construction industry has embraced the concept. This video is designed to show senior management the system's operation and its financial and time-saving benefits.
Let's look at the system more closely. Following your expressed wish to use Lubeca, the initial planning and design work for your requirements can then be carried out by the Lubeca team to your satisfaction. The Meccano design of the system then means that components can be drawn from existing stocks or manufactured by the Lubeca factory if required. These parts are, as far as possible, pre-assembled off-site and then transported to site ready for incorporation into the system by the expert Lubeca production team.
We have normally used our own team to do it, but having people that are trained, they're more cost efficient.
By maintaining this full in-house operation, Lubeca achieves very high quality control of the materials used and the end product. The Lubeca system requires very few skilled tradesmen to operate it, and labourers can be easily trained to handle most of the system because of the Meccano type design, an excellent cost saving. For instance, both the main internal and external forms or shutters are all prefabricated to size off-site. They are a very effective combination of high-quality steel and either non-stick 17 to 19 millimeter plas ply covered with fiberglass, or metal-covered purlins, depending on their reuse factor. They are easily transported in bulk and on-site are easily craned into position. They provide ready-made formwork for the duration of the job, saving time and money. Following the base pour, which incorporates the first set of shear key pockets, the shutters are removed and the jacking beam and the shear key beam with shear key feet, the hydraulic and the dropper columns, all pre-assembled off-site, are craned into position and placed in these shear key pockets. Note that both the jacking beam assembly and the shear key beam are supported by and can fit into the one common shear key pocket, a unique feature of the system. The appropriate working platforms, accessways and ladders are then completed and the whole system braced to ensure safety. The internal shutters are then hung from the adjustable support arms on the dropper columns, a new and important feature which we will discuss in more detail in a moment. Once all internal shutters are in place, they are plumbed, levelled and braced, ready for the grid work. The grid work, which has also been pre-assembled off-site, can then be placed across the top. While in principle, it is essentially designed specifically for each job and site. The top working deck is then placed and secured. Because the hydraulic rams used with the Lubeca 2 system have a huge 20-ton capacity, heavier grid work is possible, allowing greater space between the grid beams, which in turn allows uninterrupted rapid pouring of the walls. This 20-ton ram capacity means proportionately fewer rams in relation to the size of the core, which also means fewer lines, leaks, potential damage, and easier levelling during the lift. Once the grid beams are in place, the external shutters can be hung from the grid via the suspension bolt and fitting. Then the external scaffold hangers or T-hangers are put in place. These scaffold hangers have supports for all necessary handrails and platforms, which are then attached. At this point, the basis of the structure is in place, and the prefabricated external protective cladding can be positioned. This cladding means that the workers are operating in a closed environment, which provides excellent protection from the elements. The fitting of lights, hydraulic lines, power pack and amenities sheds can then be finalised. After the placing of all necessary built-in items, blockouts and steel reinforcement, all forms can now be closed, ready for pouring the concrete. Once the concrete has solidified, the forms can be stripped and the system raised to begin the process of forming and climbing all over again. It is then that we really see the advantages of the new Lubeca system. Because the Lubeca 2 system is using independent structural members, droppers, between the gridwork and the shear key beams, every shutter is able to be individually suspended, and therefore all shutters and formwork can be moved and adjusted as required for the placing of reinforcement, blockouts, rebates, bond blocks and doorways. This adjustment also makes plumbing the system very straightforward because all shutters are totally adjustable 3 ways: vertically, horizontally and laterally, via the dual bracket on the internal forms and the suspension system on the external forms. This means that plumbing the system is very simple and extremely accurate. Because they are independent, moving the shutters does not alter the upper deck alignment. The surveyed alignment points taken on the upper deck will therefore remain accurate throughout the plumbing process, and the alignment of boxes can in fact be perfect. Accuracy is more dependent on the care of the operator than the ability of the system.
In controlling it, we can control it within plus or minus 3 mil. the accuracies we've been obtaining have been within plus or minus 3 mil. On previous systems, the accuracies varied up to 20 mil, 25 mil at times, but normally speaking they were within about 10 mil. So this system is quite capable of being maintained within very tight tolerances.
If space is tight, access for placing reinforcement, etc., can be gained by lowering any internal shutter by means of an electric winch. This feature is unique to the Lubeca system and provides unparalleled access for the placing of steel reinforcement, blockouts and so on. And because the hydraulic rams are below the upper deck, that deck itself is now totally clear to allow easy access to any area, a clear area upon which reinforcement and materials can be craned, and plenty of space for sheds and toilet facilities. It also means that there is no delicate machinery on top of the deck which could be vulnerable to damage from the inevitable knocking by cranes or spills or splashing from concrete pours. The concrete pours themselves are a much more efficient process because of the freedom of worker movement and access. Covers can be lifted and replaced at will, making for additional ease of movement and safety. Once the concrete is set sufficiently, the shutters can be released and the whole system simultaneously raised via the hydraulic rams in 20 to 30 minutes.
We are able to achieve a 4-day cycle, which therefore gives us our cost efficiency and cost savings for the project.
Additional safety factors in the rams include non-return valves, a complete hydraulic backup system, and a special non-return ratchet locking device on each ram. One of the main features of the Lubeca system is that it does not have to rely on the most recent concrete pour for support of the system. Because the hydraulic rams have a stroke of over 4 meters, the entire structure can be lifted from one floor level to the next the day after pouring, because the jacking beams are situated in the shear key pockets of the previous pour. This effectively halves the cycle turnaround, allowing preparation for the next level to commence as soon as the system has been lifted. Once that concrete is set completely, the shear key feet, which have been raised to the upper pocket for stability, can now take the weight of the system and support the raising of the jacking beam to that same pocket, in anticipation of raising the system the next time around. The long capacity of the rams also means that the Lubeca system can cater for one single pour of up to 4 meters in height, which is of particular advantage for areas such as computer floors. Additionally, with the Lubeca system, there is no limit to core size or shape, the number of shafts, stairwells or utility rooms. As this completed structure clearly indicates, the Lubeca system is not limited to high-rise, but can also prove economical for low-rise structures, eliminating cranage requirements for the centre core operation.
The main thrust of the system for us was not so much time, but total independency from the crane.
The flexibility of the system will also allow variation in core arrangement as the core rises, either adding or deleting elements as the project progresses.
The versatility of the changeovers of floors, at motor rooms and so on, and the flexibility of it is excellent.
And the accuracy of the system means that lift installers require a great deal less packing for lift installation, saving further time and money.
We also obtain a lot of benefit to the fact that it has been able to maintain very good dimensional tolerances. In fact, we have gone into half shafting the lifts, and you're relying very much upon the accuracy of the system to be vertical. And fortunately, through good management and good system, that's been obtained. We've had no trouble whatsoever with the verticality of the cores.
Lubeca are the specialists in service core construction. Heinrich Schmidt designed the first system 15 years ago, which is now in use worldwide. Years of working with this system have led to the revolutionary design of this Lubeca Mark II hydraulic jump form. It is a totally unique concept offering builders and developers a rare opportunity to substantially reduce labour costs, manpower deployment and construction downtime. Leading Australian and international companies have recognised the benefits of the system to improve their construction quality and efficiency.
Max Braden Associates have been associated with the construction industry in high-rise development for approximately 10 years. During those 10 years we've come across most major lift plumbing systems or lift core systems, and the latest Lubeca system we've found to be far superior to the other systems that we've been operating with. They're making our job far easier. There's certainly a cost saving to the builder, and all over I think it's a far better system. It's a much more stable system. On this particular system we can actually set a theodolite up on the top deck and do a survey of the top deck if necessary, whereas in previous systems that was totally out of the question.
To make your next core construction more efficient, cost-effective, accurate and safe, call our nearest agent or head office direct for all the information on the Lubeca Mark II hydraulic jump form system. Lubeca, world leaders in formwork technology.